Alright guys, today's goal, the learner will understand how to write and apply exponential and power functions. Okay, so let's take a look at our first example here. It says, write an exponential function, y equals a times b to the x, whose graph passes through the given points. Okay, so if I set this up, and I can say 6 equals a times b to the first. Or I could set up 24 equals a times b to the third. So what I'm going to do here is I'm going to take this equation and solve it for a. So if I divide by b, you get 6 divided by b equals a. Now what you can do is take this a value and substitute it into the second equation. 24 equals 6 divided by b times b to the third. Well then 24 equals 6b squared. Divide by 6. Since we're dealing with exponential and power functions, you're not going to have the negative root, so you don't have to worry about it. You take the square root, you get b equals 2. Well, now that I know what b equals, take that b value, plug it in right here to find a. A equals 6 divided by 2, so a equals 3. So you get the equation y equals 3 times 2 to the x. So let's take a look at another one. Okay, same sort of thing here. We have, remember that's an x, that's a y, that's why we can do this. So we say 8 equals a times b squared, or 32 equals a times b to the third. Well, if I solve this one for a, divide by b squared, you get a equals 8 divided by b squared. Plug that in, 32 equals 8 divided by b squared times b to the third. So you get 32 equals 8b, because this is like being over 1. So 3 minus 2 is 1 on the top. So I get b equals 4, so plug that in over here. So you get 8 over 16, so a is 1/2. So our final equation, y equals 1/2 4 to the x. Let's take a look at one more. Alright, so again, we have an x, we have a y, we have an x, we have a y. So if we set up our equations, 8 equals a b to the third. 64 equals a b to the sixth. Now we get, solve this one for a, so divide by b to the third. A equals 8 over b to the third. Then what we do here, take this value, substitute it in for the a over here. Okay, so then you get 64 equals 8b to the third. Divide by 8. Cube root. So you get b equals 2. Take that 2, plug it in over here. So you get a equals 8 divided by 2 to the third. A equals 8 divided by 8. So a equals 1. So that would be y equals 1 times 2 to the x, or just y equals 2 to the x. So let's look at some other things to deal with exponential and power functions, guys. Okay, so it says here, in examples 2 and 3, that's in your book if you want to go to 4.7 and look at them, how would the exponential models change if the scooter sales were shown in the table below? Okay, so what I did here was I took these tables, put them into list 1 and list 2 in your calculator. If you don't know how to do this, I'm going to put it on you guys to find me and I'll show you how. But remember, you go stat edit and there's list 1, enter the numbers, list 2, enter the numbers. Okay. Now, example 2 shows us what they want to do is take the natural log of the y data. Okay, so watch. So what you do is you go over into list 3 and you do you highlight at the very top of the list 3 and you say natural log of list 2. And it does natural log of the y data. Okay? And then what you do is you go to stat calc number 8, which is linear regression, and you do L1, L3. If you do that, you're going to get what I'm about to show you. Okay, see how it says linear regression? Because that's what number 8 does. A plus bx, and it tells you what a and b equal. So when we go to write this equation, you're going to get the natural log of y, because that's what we did, equals 2.43 plus 0.37 x. Okay. Now what we need to do is solve this for just y instead of natural log of y. So you got to go e to this power on both sides. So you get y equals, because those are inverses, e to the 2.43 plus 0.37x. But remember, why did we add the exponents? Because they have the same base. So I can change this to y equals e to the 2.43 times e to the 0.37x. I use the calculator and do e to the 2.43. You get y equals 11.36 e to the 0.37x. So there's our exponential equation. Now I'm going to show you one more thing you could do, though, to check. So hang on 1 minute. Let's see if we look at this. It's saying A is equal to 11.39, B is equal to 1.45. Regression. Now, we're going to do something else with this, so watch. If I go y equals 11.39, 1.45 to the x. But this one here, we could have changed to 11.36 e to the 0.37 to the x, because power to a power you multiply. So if you use your calculator and do e to the 0. You get y equals 11.36 times 1.45 to the x. See how these are almost identical? That's using different regressions to be able to calculate things. Okay? So let's make sure we know how to do these. And again, see me outside of class if you don't. Okay, now we're going to write a power function, y equals a times x to the b, whose graph passes through the given points. It's still a very similar process, though. You're still going to say 1 equals a times 2 to the b, and 6 equals a times 7 to the b. But then what you're going to do is still solve this one for a, so divide by 2 to the b. So a equals 1 divided by 2 to the b. Plug that in over here. 6 equals 1 divided by 2 to the b times 7 to the b. So what you have here is 6 equals 1 times. So you have, see how we have 2 to the b and 7 to the b? That means I can change that to 7 over 2 to the b. Because they both have that exponent of b, it's the same thing as this. Okay? Now what we need to do, though, is one, you would say 6 equals 3.5 to the b. And then you need to change it from Ben to the log of Benny. So you would say log 3.5 of 6 equals b. And then that would be log 6 divided by log 3.5. And b would be approximately 1.43. We still have what a equals right here. Okay? So, a equals 1 divided by 2 to the 1.43. Use your calculator. You get a is approximately 0.37. So our equation, y equals 0.37 x to the 1.43. Okay? So let's take a look at another one here. So again, 8 equals a times 5 to the b. 34 equals a times 10 to the b. Solve the first one for a. So you get a equals 8 divided by 5 to the b. Then substitute it in over here. So 34 equals 8 divided by 5 to the b times 10 to the b. And then we can separate these things. So you have 34 equals 8 times 10 divided by 5 to the b. 34 equals 8 times 2 to the b. Divide both sides by 8. You get 4.25 equals 2 to the b. Change it from Ben to the log of Benny, so you get log of 2 of 4.25 equals b. And then we got to do common base to get base 10. So you get that. So log of 4.2, log of 4.25 divided by log of 2. We get that b is approximately 2.09. Plug it in over here. A equals 8 divided by 5 to the 2.09. A equals 0.28 approximately. So our equation, y equals 0.28x to the 2.09. So there's exponential and power function, guys. See you tomorrow.